Hey there, in this video we are going to start a new project using TypeScript and React. Before we go into the details of how it works, let me give you a quick demonstration. So this is a quiz game. We're going to receive random questions about any category we choose. So here, let's try to answer this one. Which of these founding fathers of the United States of America later became president? I think it has to be Samuel Adams. So let me submit. And now it's just telling us that the answer is wrong. It's showing us the correct answer. And now the score has been updated. Let's try a new one. Let me guess 107 BCE. Let me submit. And now, as you can see, we have some nice visuals and sound to let the user know that the answer is correct. So I worked really hard to make a very cool user interface for this project, and we are using the Open Trivia API to get random questions. So this is the API that we are going to use. They have more than 4,000 verified questions, and you can choose between categories. For example, if we go to API, we can see all the categories we can choose here. So we have many options for our game, and every request we make to this API is going to provide us with a random question that we can present to the user. So for this project, we are going to practice a bit more about TypeScript. We are going to learn how to use TypeScript with things like the context API and reducers. So I can't wait to get started with this. Now let's open the initial version of Visual Studio Code so we can get started. So make sure to download the zip file. Once you download it, just go to File, Open Folder, and you can then open the React TypeScript quiz game initial. Now here we have a few errors. This is probably because we didn't install all dependencies yet, so let's make sure to do that. Let's go to a new terminal and let's run npm i. Now we can see that all the errors are gone. Now let me run vite. So going back to the browser, you can see that all HTML and CSS is done as usual. Of course, nothing here works because this is just a static page. We can't select anything. We cannot click any button. So this is just the HTML and CSS structure so we can get started. All the logic is going to be built in this section. So taking a look on what we have on Visual Studio Code, we already have some TypeScript components, but I didn't write any TypeScript code yet. So this is going to give us the opportunity to start this project from the beginning. All right, so now that we know a little bit more about this project and we have the initial version open on Visual Studio Code and on the web browser, we are ready to move on to the next video so we can get started. Hi there, in this video we are going to create the context for our application. We are not going to need Redux for this project. We don't need to have different slices. So for this, the context API is going to give us all we need to control the state effectively. So to get started, here inside the root folder, let's create a new file for the context. So I'm going to call it quiz context.tsx. Now let's go to the documentation so we can remember the steps for creating the context. So here in the documentation under installation using TypeScript, we can scroll down and we will have examples with use context. We also have with use reducer, which we're going to need a bit later. So first, let's start by creating our context. So let's copy a few lines of code from here. And then let's adjust for our case. Now here we are going to have a few warnings because we are not using these things yet. We can just ignore them for now. So here we can see that there's this type. This is an example of a context for a theme. So we need to adjust this type to match what we are going to build right now. So right here, instead of using the theme, I'm going to create a new type and I'm going to call it quiz state. So here we are going to build the template for the object of our state. So we are going to define all the properties we will have in the context, and all the data types that these properties can have. And by doing that, TypeScript will help us write valid code and will help us catch errors while we do things. So here, since this is an object, I'm just going to use interface, and let's delete all of these things. And this is going to be the template for our state. Now to get started, I'm just going to create one property now called game status. Let's not go into the questions and answers or the score yet. Let's start with simply the status, because if we go back to the original project, the completed version, we will see that every time we load the page, we have this loader. And when we select a new question, so let me just answer this one real quick. Let me go to a next question. We see the loader again. So this is based on the game status. Every time the game status is loading, then we are going to show that loader. So let's start the context with this property only, so we can test everything, see if we can feed the child components with the context, then we can move on to other properties. So for the game status, this is going to be a property, and this can only receive specific values. We could define this as string, but then TypeScript is not going to help us much. We need to define the exact values that we can receive here. So when we write logic regarding the status, TypeScript is not going to let us use invalid values. So here we are going to start with idle, which is going to be the initial value. This can also be fetching or loading, which is going to be when we show that loader we just saw on screen. We have one called ready. And for now, this is all we need. Later, while writing the logic, we may want to extend this, but for now, it's just idle when we load for the first time. There's fetching, and when we receive the question, there's the ready one. Now, this is going to be the type for the context. So here is where we declare the type of the context. So again, TypeScript is not going to let us use anything for the context that's not defined here. And this is a very good thing. This is the first example. We are trying to create the context with this default value, but this is not going to be allowed because now the state is strongly typed. So we need to have an object with this exact shape. In order to do that, let's create a new variable for our initial state. Let me just change this name to quiz context. And now let's create a new variable that we are going to call initial state. So this is going to be an object, and this is going to have a property called game status, which is going to be set to a valid value. So let's try idle. Now we are going to get the initial state, and we are going to pass here when we create the context. Now we are having this problem here because even though we have, it seems to be the correct shape, if we hover over this variable, we can see that TypeScript is not inferring this type as quiz state. TypeScript is inferring as this specific object. So if we do the type annotation, now TypeScript has the type correctly. So now this operation is valid. Now we are ready to go ahead and create the provider for the context, but I'm going to break this video in two parts so it doesn't get too long. So let's go to the next video so we can start creating the provider. Hey there, in this video, we are going to create the provider for our context. So let's create a new function. Let's export it because we are going to need to import it from the app component. So this is going to be a function called quiz provider. Now inside here, let's create a state variable for now. We are going to use a reducer instead, but creating the context is already complicated enough using TypeScript. Things are a bit different than what we are used to do. So let's do it with a state variable first, and then we can add the reducer on a separate video. So I'm going to create a new variable and I'm going to call it state and set state. So let's use the use state hook. And as the initial value, we are going to pass the initial state. Now here we are going to return our component. So this is going to be quiz context dot provider, and the value is going to be the state. Now here, in order to import this provider from wherever we want and just place components inside, we need to use the children prop. So we need to pass it as a prop right here. And we know that with TypeScript, when we have props, we need to declare the type of the prop. This is not a normal prop where we pass a string or a number or an object. This is a special type of prop that can accept React components as well. So let's go back to the documentation so we can check something. So right here under installation using TypeScript, let's just press Ctrl F and search for children. So as you can see, we have a few options of types for the children. So we either use React Node or React Element. And what's going to be the difference here? If this was a normal children prop where we can pass a React component or maybe an HTML element like an age1 or even a piece of string, then it would be better to use React Node, because React Node is a union of all the possible types that can be passed as children in JSX. So it would be completely fine to use this one. But in our example, since for that provider, we are only going to pass elements inside, so we are going to place it around the app component, we can just narrow this down and use React Element. So then as children, we are going to accept only React components. And we can see here that we can create an interface, but in this case, since we just have one prop, we can just declare the type when we create the prop. We already spoke about this in previous videos. So if we have more than one prop, it is better to create an interface. But for this case, I think it's just fine to add it with the props. So let's copy this. And let's remember that we need to pass the object, and then we need to define the type. And here we will pass the type, which is an object with one property called children. And the type of the children is going to be a React element. Again, if you want to create an interface for this, it is fine. But since we just have one prop for the provider, I think it's okay to do that. In the end, you will see that we're going to have to create more interfaces here. So if we can save some space with this one, it is a bit better. All right, so now we created the component for the provider and we are already exporting it. So we can go ahead and use the provider. So let's go to the main.tsx file. And right here, we are going to import the quiz provider from the quiz context file, and we are going to use it to place the app inside. So here, let's add the quiz provider, and inside we are going to place the app. Let's remember that this is exactly the reason why we added the children. So we can place anything we want inside. In this case, we are going to provide the app, meaning that everything below the app structure, which is the top level component of the application, will have access to the context, which is exactly what we want. So we can save this, and now we just need to start using the context. To make it easier, let's do the same thing we've done before, which is creating a function to use the context. So we are going to export a function and let's call it use quiz. This is an optional step. You could completely write this code from every component, but I just think it's easier to have a use quiz function. And what this is going to do is just return use context, and then we are going to pass the quiz context. Now this is the function that we are going to use on every component that needs to read from the state or to alter the state. So now let's go to the app component and let's make a quick test. Let's import use quiz from the quiz context.tsx, and here we can create a new constant called state, which is going to come from the use quiz. Now we can go ahead and send the state to the console. So we save this, we go back there, let's open the inspector, let's go to the console, let's open this object, and as you can see, we successfully created the context, provided the context to the whole application, and now we have access to that property called game status. So now we are ready to go to the next step, which is adding the reducer. It is better that we do this now because then it might be more complicated to adjust the context. So now that we are just starting out, we only have one property. Let's go ahead and add the reducer. So all mutations we want to do in the state will have to be done through the reducer function. So let's go to the next video so we can get started with that. Hey there, now that we successfully created the context and we provided it for all the components of our application, now it's time to add the reducer. This is because we are using a state variable, so every mutation that we want to do to the state will have to be done from the child component, and this is not going to be very predictable. Ideally, we need to know all the actions we can take over the state, and also we want to use TypeScript to make sure we only call valid actions and we pass in valid data. So to create a reducer, let's go to the documentation. Under using TypeScript, let's search for use reducer, and now we can use this example. So we can see that it is suggesting that we have an interface for the state, which we already have. Let's remember that we have one called quiz state. And now it is also suggesting to create one for the actions. And this is indeed a very good idea, because if we strongly type all the actions, and not only for the types, but also for the values that each action can receive, then whenever we call these actions, TypeScript is going to let us know if we are writing invalid code. So let's copy this type, and right below the quiz state, we can add one for the quiz action. Now, as you can see, instead of using an interface and just add the type, we're going to pass different shapes of objects. And this is going to be great because this is going to allow us to strongly type the values passed through the actions as well. So in this case, we don't have an action for reset. Let's just start with one to set the game status. So we are going to call it set status. And here we are going to have a value property that will be mandatory, which means that we can't call this action by mistake without a value. We are going to have to pass a value. I'm just going to name it payload instead, because this is going to be the default value that we're going to use for all actions. So we are going to pass something as the payload, and as the payload, it has to be one of these values. So what we could do here is add the quiz state and the game status property. If we do that, we are going to use these values. So if we hover over payload, we can see that TypeScript is now restricting the values to these three options. So this is one way of doing this, but I think it's even better to create a specific type for these values. This is because if we need to export it later to use on other components, it's going to be easier than having it inside the quiz state. So what I'm going to do here is the following. I'm going to create a new type, and I'm going to call it status. So this is going to be the combination of these three values. Now here, instead of displaying them here, I'm going to use the status type I just created, and here I'm going to use it as well. So this is the same as we had before, but now if we need to import this from other components, it's going to be easier. We can just export this type and use it on other components. All right, so now we can go back to the documentation and continue. So now it's time to create the reducer. Let's copy all the reducer function. And I'm going to add it at the bottom. And I'm going to call this quiz reducer. So this is going to have a state, which is going to be of type quiz state. And this is going to have an action, which is going to be of type quiz action. Now this is what the reducer will return. Let's remember that we are always going to go inside the reducer with a state, do the mutation, and then return the state. So what we have outside of the parentheses is where we declare the return value of the function. So this function is always going to return the state, which in this case is going to be of type quiz state. Now we have the switch statement, and for now, let's just leave one action and one default case. And now that we have the action strongly typed, as you can see, TypeScript knows that this action is not valid. We don't have an action called reset, and we can also use the autocomplete. So when we add a new case, TypeScript is going to give us the only options we can use. In this case, it's set status. So in this case, what we are going to return is the following. We are going to get the state and use the spread operator, and then we are going to change the status only. So in this case, we are going to do game status, and we are going to assign whatever value we pass in the action dot payload. Now the cool thing here is that everything is strongly typed. So for example, if we try to add a property that does not exist in the state, for example, status, it is going to let us know that status does not exist on type quiz state. So we won't be able to make mistakes like this. And again, if we pass the wrong name for this property, for example, value, it's not going to let us because we don't have value, we only have payload. And when we dispatch these actions from the child components, the same validation is going to be done, meaning that it's going to be much easier for us to write valid code in one go. All right, so now this is done. So the last step is just removing use state and replacing by use reducer. So at the top here, instead of use state, we are going to bring use reducer. And let's go back to the documentation and let's remember how we need to pass this. So I'm just going to break a line here, and here we need to pass the reducer, which in this case it's called, let me just check the capitalization. So quiz reducer with a capital Q, and the initial state. Now here we can see that I mistyped this variable name. I'm using initial state, so it is a good time to correct this. As you can see, this would be something that maybe I wouldn't even notice I did wrong. So what I'm going to do is I'm going to replace everywhere where I incorrectly named initial state to initial state. So now we don't have any errors anymore. And let's remember that instead of having set state, we are going to have something called dispatch. So here we are going to have dispatch instead. And the dispatch is going to be the method we will use to call our actions. All right, so now the reducer is done and we just replace the use state by the use reducer hook. This is going to make things much more predictable and will allow us to take full advantage of TypeScript. But before we are able to use the reducer on child components, we are going to have to adjust one thing first. And this is the subject for the next video. I'll see you then. Hey there, in this video we are going to test our reducer. So we know that we can bring in the state from the quiz context, but now we need to test the reducer. And I will tell you in advance that there is something that we will need to adjust. So in order to bring specific properties from our context, we are going to add the curly braces right here. And we are going to bring both the state and the dispatch method. Now, as you can see, we are having an error. So this is telling us that property state does not exist on quiz state, and the same for dispatch. And why is this happening? Let's go back to the context, and let's remember that when we created the context, we defined the type for the context as quiz state. And as an initial value, we are passing the initial state. So this would be fine if we just wanted to provide a value to the child component. So if we just wanted to provide the status for them, we could have created it like this. But in this case, we also need access to the dispatch method. So for that, we're going to need a new type for the context, which is going to include the state and dispatch. So at the top here, let's add a new interface and let's call it quiz context. So the context is going to have a property called state, which is going to be of type quiz state. And it is also going to have one called dispatch. And the type here is going to be a built-in React type, which is called dispatch. So we can just call React.dispatch. And what we are going to pass through this method is going to be a quiz action. Remember that we are strongly typing the actions to take more advantage of TypeScript. So here we are going to pass a quiz action. Now, when we create the context, instead of using the type as quiz state, we are going to have the type as quiz context, which means that we now have to pass an object that looks like this. So we are going to pass an object instead. We are going to pass the state as initial state. And now we also need one called dispatch. Now the problem here is that we don't have a default value for dispatch. We could pass no, but then it is not going to let us because of the type. Unless, of course, we define that this can be either no or a React dispatch type. This is one way of solving this, but the common way is just passing any function. So if we just pass an arrow function, that is going to return no, then this is going to be accepted as value. We shouldn't worry about this because remember that we are passing dispatch when we create the instance of the context down here. So this is just an initialization for the context. Okay, so now that this is done, instead of passing the state here, we are going to pass an object, and the object will have both the state and dispatch. And now that this is done, we can go back to the app component. And now we have an error because it's telling us that these elements are unused. So let's use the state right here. So as you can see, we don't have any error for the state anymore. And now we can just try to use dispatch. So for that, let's go at the bottom here. I'm going to add an age to element just so we make a test. And I'm going to show the status. So let's output state dot. Now look how TypeScript is providing the autocomplete now that everything is strongly typed. So it's going to be really hard for us to make any mistakes from now on. So let me just test this real quick. I'm going to go back to the page. And now as you can see, we are showing the status right here. So idle, And now let's create a button just to see if we are able to change the state. So I'm going to create a button. Let's add some text inside so we can write set loading. And what this is going to do is the following. This is going to have an on-click event. And when we click, we are going to dispatch something. So dispatch, which we are already importing from here. And what we need to pass through dispatch is the following. We need to pass a type, which in this case, again, TypeScript is bringing the autocomplete. So this is the only action that we have. And this is an error because this action needs a payload. So we can see property payload is missing. Now let's pass a payload. And again, we will only be able to enter valid values. So as you can see, these are the only values that we can use. So if we try a value that would produce an error, for example, loading, TypeScript is not going to let us do that. So this is the advantage of strongly typing everything. So let's use fetching, and we can now save this, go back there. So we have status idle. Now we are going to click set loading, and we just change the status to fetching. So this is pretty cool. We know that the context is working. We can provide state values to child components. And now we have our reducers in place, and we can also mutate the state. So we can now go back there and remove this, as this was just a test. For now, we can bring only the state just so we don't have that warning. And now all the setup work is done. I know this was a bit of work, but from the examples I just showed you, we can see that it is worth it, because everything we do from now on, we will have TypeScript checking for errors. So now we are ready to start writing the actual logic for our application. Let's go to the next video. Hey there, now that we finished all the groundwork to manage the state of our application from the context, we can start writing some logic. And the first thing we are going to do is fetch questions from the Open Trivia API. If we take a look at the structure of the app component, we can see we have a score and a game component. If we go back to the page, we can see that this is the score component and the rest is part of the game component. So let's go there, let's open the components folder, and let's go to the game component. So here we have an example of a question that I left here just as an example. So we can see that if we refresh the page, there will always be this question. So this is what we need to work on. Of course, this is not going to live here. This is going to be stored in the context. So for that, we are going to do some work here inside the app component. So whenever our status is set to idle, we are going to fetch a new question. And what is going to avoid us from running an infinite loop is that when we finish fetching the question, then we are going to change the status. So up here, we are going to import use effect from React, and then right here, we can call the use effect hook, and we know this is going to be fired every time there is any change in the state, and also for the first time the application runs, which is exactly what we need. So for the first time, we're going to fetch the question, then when we need another question, we are just going to change the status to idle. So let's start an arrow function right here. Now inside here, we are going to do a test. So if state dot game status is equal to idle, then we are going to do something. Let's see if this is working. So for that, I'm just going to send an alert, and I'm going to type fetch question. So as you can see, this is working fine. Now, instead of sending this alert, we can go ahead and fetch the question. So let's create a new function so we can handle that. Let's call it fetch question. And up here, we can create this function. So now let's go to the OpenTrivia API website, which is opentdb.com. Here we can go to API on the right-hand side, and then we can choose some options. So for the number of questions, we are going to bring in just one question, because if we bring more, then we are going to have to manage ourselves what questions we already showed. It is better that every time the user requests a new question, we just send another request to the API. So let's get one question at a time. For the category, I decided not to overcomplicate this project, so I'm not going to add this dropdown. Instead, I'm just going to choose one category. Later on, when we finish, if you want to implement this, this is really easy. This is just going to add one more parameter to the URL. So for this example, let me just choose something like science gadgets or maybe science computers. You will be able to change it later if you want. For the difficulty, let's just leave any difficulty, any type. As you can see, we have multiple choices and we also have true and false questions. So let's leave all of them and let's leave the default encoding. So when we generate the API URL, we can see that we don't even need an API key, which is a great thing about this API. We can just run the fetch method with this URL. I'm going to copy it and I'm going to open this on a new tab just so we can see the kind of response that we are going to receive. So this is an example of a response. If we refresh the page, we are going to get new ones. So as you can see, every time we run the request, it is going to give us a random question for that category. Now I'm seeing this formatted like this because I have an extension, so I can go to the extension. I have this one called JSON view. If you want to see JSON in the web browser like I'm seeing right here, you can just get this extension. This makes it easier to see the shape of the data. So now that I copied the address, let's go back to Visual Studio Code. And the first thing we're going to do here is create a variable for the response. And this is going to be an async request. So let's use await. And to make this work, we need to make this function async. So now we are just going to call fetch. And here we are going to pass that URL. Now here we can create another one. We can call it data. So let's use await for this one as well. And here we are going to get the response and we are going to apply the JSON method. So this is going to transform this from JSON into a JavaScript object. Now, after we have the response, let's just send it to the console so we can see what we have. So we can send data to the console. Now let me just comment this line just so we have only one thing in the console. I'm going to save this. Going back there, I'm going to refresh the page. And now, as you can see, we received this from the API. So we have an object with a response code and the results. Inside the results, we are going to receive an array of questions. We need to pay attention to this, even asking just one question. So we are going to have to go to question 0, and then we have the data we need to present to the user. So let's create a variable for the question. This is going to be data.results. And then this is going to be inside index 0. So results is going to be the array of questions. Here it is. And then we are going to get this question. So since we are going to ask one question at a time, this is always going to be inside index 0. And now that we have the question, we can go ahead and add it to the context. But before that, we need to create the interface for the question so we can keep everything strongly typed. So this is what we are going to do in the next video. Hey there, in this video we're going to create the interface for the questions so we can add it to the context. And for that, I'm going to teach you an incredible tip on how to do that using ChatGPT. Not that this one is too complicated. This one is mostly made of strings, except for this one, which is an array of strings. So this is super easy, but I decided to show you this because in the past, there were situations where I had to do the interface for very complex objects, and I had to think about all the possibilities to create the correct interface, and ChatGPT can help save a lot of time in this process. So here we are going to do the interface for this object, which is the question. And we could go to Visual Studio Code, go to the context. We could start the interface for the question right here. And then paste the object we have down here and start creating it ourselves. So for example, we know there will be a category, which is going to be a string. Then there will be a type, which is also going to be a string, and so on. Now let me show you how you can ask ChatGPT to help you out. What you can do is just get a lot of questions, so then you will know some different values that you can receive. So I'm going to increase the amount here for 20 questions. I think at least 20 different objects, so ChatGPT can analyze what are the possible types that we can have. So now we received 20 questions. I'm just going to copy this whole thing. And let's go to ChatGPT. And here I'm going to type the following. I need to create a TypeScript interface for a question. Please see below a JSON with 20 example questions so you can analyze the possible values for each property. Questions are inside the, let me just confirm here, so it is inside the results property. So now I'm going to hit Shift Enter to break some lines, and I'm going to paste that whole JSON. We press Enter. And just like magic, ChatGPT generated the interface. As you can see, I didn't even ask for the question response, but it generated it for us in case we want to do some error handling with this. This is fantastic. We can copy all this, go back there, and now you can see that it saved us a lot of time, even with this simple example. Now imagine if we had a very complex object. So I'm going to erase this, and we need to check if everything's correct. So we have a category, which is a string, then type. Now, as you can see, it analyzed all the 20 questions, and instead of defining it as a string, it defined as either multiple or Boolean, which is incredibly accurate. It even included some comments. So now there is the difficulty, same thing. Question is a string, correct answer is a string, and the incorrect answers is an array of strings. Now we have the response code, which is a number. This one we are going to use later. And we have the results, which is an array of questions. That's pretty impressive. And now we have the interface done for the question. So I hope you like this tip. Whenever you have some complex objects and you need to create an interface, just get a lot of results, get 20, maybe even more, 30, 40 results, paste on ChatGPT, and it is going to create a very accurate interface you can use. Just don't forget to verify if everything is correct. So now let's go to the next video so we can continue the work with the questions. Hey there, now that we have the interface for both the question and the question's response, we can go ahead and add the questions to the context. So the first thing we're going to do is export these two interfaces so we can use inside the app component. So now let's go to the app component and let's import not only use quiz, but also question and questions response. Now, the reason why we are importing these types or these interfaces is because when we receive data from external sources, TypeScript cannot infer the type. So we are going to have to do the type assertion right here. We know that when we get the response and we convert it from JSON to a JavaScript object, we are going to have an object for the question's response. So first, we are going to do the type annotation for this variable. And by doing that, TypeScript is going to help us work with that. So as you can see, we have here data.results and then 0. And we have no errors because this is valid inside an object of this shape. But if, for example, we try to get data.questions, then TypeScript would let us know that this property does not exist on that type. So that's the beauty of defining these interfaces. Now this one is also going to need the type annotation, and this is going to be a question. This is going to be helpful, especially a bit later, because we're going to have to modify the answers a little bit, but let's leave this for later. First, let's add the question to the context. Now the first thing we can do here is the following. We can test the response code. So if we go to the API documentation right here, we can see by the response codes that 0 is the response code for success. So any other response means that there was an error. If you want, you can create specific messages for each of these responses, but I'm just going to consider 0 as success and all other response as error. So going back there, after getting the response, we can create an if, and we can say that if data dot, and then we have the auto-completion from TypeScript. So the response code is, let's try an invalid value. So 404, which is not what we want. We want 0. And TypeScript is helping us by letting us know that this is valid. So if it is 0, then we are going to get the question. And after getting the question, we can go ahead and add it to the context. But before we do that, let's just deal with the status, and then we can go ahead and create this new action. So if we get the question, it means that everything worked correctly. So let's import this patch from the context, and when we start fetching the question, the first thing we are going to do is change the status. So we are going to call this patch, we are going to pass in a type. The only one we have right now is set status, and the payload is going to be fetching. So this is going to be helpful to set the loader. Then once we have the question, we can change the status to something else. In this case, this is going to be to ready. Now, if the response code is not 0, then we can set an error status. We don't have it yet, but we can go to the quiz context and we can add another status. So let's add one for all the error cases. Now going back there, we are going to set it to error. Now we can do the same thing for if there is a problem in the request. So we can do that by putting it inside a try catch block. So try and then catch. So if everything works correctly, we are going to handle it like this. If not, we are going to set the status to error. And we are going to send the error to the console. Now, we didn't do anything with the question yet, but we can already see this in action. So right here, before dispatching it, let me just send the question to the console again, just so we can make a quick test. If you want to break a few lines like this so it's easier to read, you can go ahead and do it. Now let's do a quick recap of what we did here. When we start the context, we set the status to idle by default. So when the application loads for the first time, we have the status as idle. Then once we load it for the first time, we're going to fall on the use effect. And if it is idle, which it is, we are going to fetch the question. Once we fetch the question, the first thing that is going to happen is that the status is going to change to fetching. Then we're going to try to fetch. If everything works correctly, then we are going to be ready. And if there is an error, we are going to change this to error. So this means that we can start building the UI accordingly. So if the status is fetching, we are going to show a loader. And this is going to be cool because this is going to work automatically every time we ask a new question. Then if the status is ready, we can go ahead and show what we are showing right now. And if there is an error, we can just show an error. So let's build this logic real quick. Now for the loader, I already left a component that's ready for that. It's a pure CSS loader. We use it in previous projects. So let's just do a quick test. If I bring in the full page loader, let's not forget to import it. So up here, let's import the full page loader. From full page loader, we can save this. And if we go back to the page now, we will see that this is the loader I'm talking about. It has no background, but it's not going to make any difference because this component is not going to be rendered if the status is not ready. So now let's go write some logic here. We are going to test first if the status is fetching. So let's do this. And if the status is fetching, then we can show the full page loader. Else, then we can do another test. If we have an error, then we can show maybe a p tag that says error. We can maybe later create a component for this. Else, if game status is ready, then we can show these two components. But the problem with these two components is that we need only one root component here, so we can do that by adding a fragment. So with this, we make sure that we have only one root element and we can paste these two inside. Okay, so if none of the above, we're just going to render nothing. And now we can go ahead and test this logic. Let's go back to the page. Let's refresh it. And now we can see the loader. And once we receive the question, we can see the game and the score, which is really cool. Now let's just test the error real quick. So if we go up here and we change this parameter to something that doesn't exist. So for example, amount with 2 M's, we can save this. We can go back there and try again. And now as you can see, we received an error. So of course we could have a better component for the error, maybe with a button to try again, but I'm not going to waste time on this right now. As long as we have the errors being handled, it's fine for now. All right, so now we can go ahead and add the question to the context so we can render it for the user. And this is what we are going to do in the next video. I'll see you then. Hey there, now that we did all the work to render the UI correctly based on the results of the HTTP request, we can go ahead and add the question to the context. So in order to do that, we need to create a new action. So let's go to the context, let's go to the reducer, and let's remember that everything here is strongly typed, and so far we only have one action. So let's add another case for this new action. Let me just adjust the indentation, and we can name this one set question. Now TypeScript is letting us know that this is not possible because we need to add it to the type. So if we go up, let's remember that this is where we are setting the possible actions. So here we are going to add more object types. Now let me add a union right here, and then we are going to add another possible object. So the type here is going to be set question, and then in the payload we are going to receive a question. Now TypeScript is telling that there is an error because if we were trying to change the game status, we can't, because we are going to receive a question here. So instead, we are going to add it to the question. Now the problem here is that this property doesn't exist yet. So let's go ahead and do it. So first, in the quiz state interface, we are going to add one for the question, which is going to be of type question. And then in the initial state, we can add a question. But since we don't have one yet, we are going to set it to no, which means that up here, we need to tell TypeScript that either we are going to have something of type question or we are going to have a no value. So now everything here is valid. And if we go down, now the action is also valid. So again, it is a bit of an extra work to set these things using TypeScript, but now we can be 100% sure that this is going to work fine. We don't even have to test it. Now we can save this, and right here we are going to dispatch that action. So we are going to dispatch set question, and the payload is going to be the question. Now it is giving an error because we must pass something of type question, which it is the case here. So again, TypeScript helping us write good code in the first go. So now we can remove this console.log, and if we go to game, let's remember that we had this question by default, but now we don't need this anymore because we are going to have an actual question in the state. So we just need to get it from the state, and we don't have to worry of it being new or anything because we already handled all the errors. So if we render this component, which is right here, it means that we already received the question and we don't have any errors. So we are going to render these components. So right here, we can import use quiz. From the quiz context, we can now delete this part right here. And inside the function for the component, we can create a new constant for the state, which we are going to get from use quiz. So here we just need to replace, we are going to be getting the question from the state. And here TypeScript is showing us some errors. So let's see what is going on. So it is telling us that state.question is possibly new. So again, here's the importance of creating the interfaces as accurately as possible. So in this case, if this is no, this is going to be an error. So we can just add the question mark right here, and we are only going to get it if there is this question property. All right, now we save this and we go back to the page to test. And I probably forgot to change this property back. So this parameter, so putting it back. So now we are getting a new question and we are rendering it to the user. We can try again, and there will be a new question, and again, a new question, again, a new question, which is fantastic. So this part is almost done. We just have to adjust something with the answers. So let's go to the next video so we can continue. Hey there, in this video, we're going to have to do a little adjustment with the possible answers for the question, and I'm going to show you right now what I'm talking about. So right here, I'm going to send the question to the console. So let's send state.question. Let's save this. Let's go back there. So here it is. We can see that we have the incorrect answers in one array and the correct answer separately. So this means that what we are showing here to the user are just the incorrect answers. So we need to make sure to put the correct answer here as well. And we need to make sure that this is shuffled because we don't want to place the correct answer every time on a specific position. So every time we get a new question, we are going to place it on a random position inside this array. So let's go back to Visual Studio Code so we can do that. Let's go to the app component, and when we fetch the question, so right here it means that this happened correctly. We are going to set the question, and then before dispatching the set question action, we can do the work needed. So the first thing we need to do here is to get a random index. This is because with this random index, we are going to decide where we are going to place this question. Let's go to the browser, and here in the console, I'm going to do some tests to show you what is my idea. So to place that correct answer in the array, we can use a method called splice. So let me add an array as an example. I'm going to name it R1, and I'm going to have an array here. Let's say 1, 2, 3, 4. And now if we want to add an item to this array on a specific position, we can use the splice method. So we can do R1.splice, and here we are going to tell where do we want to place this new item. In this example, I'm going to add it right here. So at index 2. So this is index 0, 1, and I'm going to place right here in between 2 and 3. So I'm going to use 2. Then how many items we want to delete? In this case, we don't want to delete any item. We just want to put it in the middle of 2 items. And now the third argument is the item that we want to add there. So for this, I'm just going to add a test, let's say number 99, just so we see how this works. I'm going to press enter, and if we go to R1, we can see that now we got this new item and we add it at index 2, and then it pushed the other elements 1 item ahead. So this is exactly what we want to do. We want to get the correct answer and add it to the incorrect answers array. But we want to do that in a specific index. And for that, we're going to have to use math.random. So let's see how this method works. If we do math.random, we are always going to get a random number between 0 and 1. So we can call it many times. This is always going to return a random number between 0 and 1. And what does it have to do with the array? Well, if we do math.random and we multiply by the length of the array, so we can do r1.length. Actually, it's r1. Then this is going to return a number between 0 and the length of the array, because let's say that the random method brings 0. So if it is 0 times the length of the array, it's going to be 0, which is a valid index. Now let's say the math.random returns 1 or 0.99. This is going to return something close to the length of the array, which is also a valid number. Then this item is going to be included as the last item of the array. Now the only thing we have to do here is round all of this. So if we do math.round, then what we're going to have is a random valid index for this array. We can test this out. So this array now has 5 items. And here we would place the new answer in index 3. We run again, index 1, index 3. We can run it over and over again. Now index 0, which would place it at the beginning of the array. 2, 4, 1, 4. So as you can see, with this, we can get a random position in this array. So this is just pure JavaScript. I really enjoy solving these kinds of problems. So now let's copy this and let's bring it to Visual Studio Code. And the first thing we are going to do is create the random index. So let's create a variable called random index. And we are going to place all that, but we are not going to get it from R1. We are going to get it from question.incorrect answers. So now we are going to have a random index. Now we just need to add this to the incorrect answers. If you want, you can create a new property for the question, maybe called all answers. Then you would just have to adjust the interfaces. But here, for the sake of simplicity, since the incorrect answers is an array of strings anyway, I'm just going to add this option to the incorrect answers array. This is not very good because of the name of this property, but just to save some time, this is what I'm going to do. So let's do question.incorrectanswers.splice, which is the method we use to add an item at a specific position. The position is going to be the random index. Then 0, because we don't want to delete any items. And the item we want to include is question.correct answer. So by doing this, we can save and go back there to test. I will refresh the page. And as you can see, let's just open the question so we can see. We have the incorrect answers, which now includes all the answers. So we have 4 options, which are being shown here. And we have the correct answer on a separate property, which we can see is 2005. So it is okay to have all of them right here, because in the end, we are going to compare the answer with this property. So we can see that right now, the correct answer has been added on index 0. But this is now random. So if we refresh the page, now we have a new question, and we can see that now the correct answer has been placed in the end of the array. We can test one more time. And this time it has been added in index 1. So now that we are rendering all the possible answers correctly, we can go ahead and get the user answer. But first, let's go to the next video so we can fix this problem here with the HTML entities. So I'll see you then. Hey there, in this video, we need to do a quick fix for the question and the answers because we are receiving some HTML entities. If I inspect this, we can see that this is a code for an HTML entity, and this is for the quotation mark. So this is how this was supposed to look. So we have a quotation mark here and another quotation mark right here. So this is how it should be showing. Now, this is something that it's easy to do. We have some libraries that can do that work for us. So let's go ahead and look for one. We can type npm HTML entity decode. So as you can see, there's one called HTML entities. which is super simple to use. We just have to install it. Then we import. It can be either encode, which is going to be the opposite of what we want, or we can use decode, which is going to get these symbols and transform them into the value we should be seeing. So let's install it first. I'm going to copy this code. Let me open the terminal. And now we can go to the package.json. We can see it has been included as a dependency. Now going back there, we can import decode. So this is the one we need. And now we are going to need it inside the game component where we have the question. So let's import it right here. And we are going to decode this HTML. And we are going to do the same thing inside the answer option. So you can see here that I left this loop done, just so we don't have to waste time on this. So for every possible answer, we are rendering this, and we can either decode it inside or we can do it right here. But the problem of doing it here is because later we are going to have to compare the answer selected to the original answer we have in this array. And the original answer will have those HTML entities. So it is better that we don't modify the original array. It is better that we just decode to show the correct thing for the user. So let's go inside the answer option. We are going to import it here as well. And then before showing it to the user, we are going to decode. But this is not going to modify the original value, so we can compare if this is correct later. So let's save this and this one. Going back there. Now let's try again. I'm going to refresh the page until we see an example of that. So now we can see the quotation marks right here. If we go to the console to see the original question, we can see that it was coming with the HTML entities. So now we successfully decoded this HTML and we are showing a readable question to the user. So we are now ready to move on to the next video. Hey there, in this video we are going to work on collecting the user's answer. Right now, if we click on the options, nothing is happening. And if we go to the final project, we can see that when we render the question, we don't even have any button down here. So we can only submit something if we have an answer selected. So when we have an answer selected, we can now see the submit button and we can see our answer being highlighted. If we click another item, we can see it changing. So this is what we're going to work on in this video. So let's go back there. And the first thing we're going to do is add the user answer to the context. So let's go up here. Let's get the interface for the quiz state, which is right here. So besides the question and the game status, we're going to have the user answer. Let's remember that for the incorrect answers, we have an array of strings. So every possible answer is a string, and this is going to be the type of the user answer. So this is going to be a string. However, it can be no. In fact, it is going to start as no. This is how we're going to test if we should show the submit button or not. So now we can go down here and we can add the user answer, and this is going to start as no. Now going back to the game component, I'm only going to show the submit if we have an answer. And for now, I'm also going to comment the result because I don't want to be showing the result before it's time to show it. So let's comment this and let's work on the submit part. So here we are going to set a test if we have something on state.user answer. If we do, then we are going to render the button. Now, if we save this and we go back to the browser, we can see that when we first rendered the question, we are not seeing the button. We will only see the button after selecting an answer. So now we need to work on selecting an answer. So basically, when we click on an answer, we are going to set the user answer. So this is going to have to be done from inside this component. So let's go inside the answer option. And when we click on this P element, we are going to dispatch that action. Before we do that, we need to create that action. So let's go to the context, and right here, let's create a new action. So we are going to add another type for this union, and the type is going to be set user answer, and the payload is going to receive a string. Now we can go to the reducer. Now here, let's add the case for that. So this is going to be the set user answer, and we want to change the user answer to whatever we send in the payload. So now let's go ahead and dispatch this action inside this component. And for that, let's just copy some lines of code from the game component. Let's just bring the use quiz for this one as well. And let's create a variable so we can get the state. And let's place it inside here. Now, instead of bringing the state, let's bring dispatch, because this is what we are going to need to do when we click the button. So when we have an on click, so now let's add an arrow function, and we are going to dispatch something. We are going to pass an object, and the type is going to be set user answer, and the payload is going to be the answer. For the answer, I had already, from the initial version, this set as string. I think this was the only line of TypeScript code that I had already done. So since the user answer in the context is a string, we can just do that. So we are going to get this answer, and we are going to set it as the user answer. Now, if we save this and we go back to the browser, let me just refresh the page. We can see that the submit button is not showing. Once we click an option, we now have an answer in the context. So we are now seeing the submit button. Now, the only thing we have to do is to reflect the selected answer in the UI. So let's go back to Visual Studio Code, and this is going to be done through the use of a class. If we go to the CSS file for the answer option, you will see that we have the P, and we have a specific border set to when the P has a class of selected. So this is the class we are going to apply to reflect that on the UI. So let's go back here, and on the P, so let me break one line here, just so we can see things better. We are going to add a class dynamically. So we are going to test something. Remember that this is a loop. When we are in the game, we are getting all the answers, and for each of them, we are rendering this component. So what we need to do inside here is the following. We need to compare if the current answer is the same as what we have in state.userAnswer. Now here, it is showing an error. This is because we are not importing the state yet. So let's bring it from the quiz context. So if this current answer has the same string as the user answer, then we are going to add a class of selected. If not, we're just not going to add any class. So now we can go ahead and save this and go back there. Let me refresh the page so we see the question being posed. We are going to select an answer, and when we do that, not only we see the representation of the selected answer, but we also see the submit button, and we can change our choice before we submit. So now this part is done. We are ready to move on to the submit logic. So I'll see you in the next video so we can start working on this. Hey there, in this video, we are going to work on the submit button. So let's go to Visual Studio Code, and inside the game component, we have this button to submit the answer. And the logic for this is going to be extremely simple. So what we're going to do here is the following. When we click this button, we are just going to dispatch an action. So let's just bring the dispatch here as well. And here we are going to call the set status action, and we are going to pass as the payload a new value. So remember that idle is when we first load the application, then fetching is when we start the HTTP request. If we have an error, then we have the error status. And if we get the question correctly, we change the status to ready and we pose the question to the user. And now we're going to add another one, which is going to be the answered. So we have to go back to the context and we need to add this status. So let's go down here and let's add another union. So let's add the answered status. So going back to this component, this is the only thing we are going to need to do in this button for now. Now let me just point out that what we are doing here is called declarative UI. With declarative UI, most of the things that we are showing on screen will depend on the status of the application. This is a modern approach for building UIs, and this makes things really simple because we just need to set the correct statuses and everything will be correctly reflected in the user interface like magic. If you want more information about declarative UI, you can just go to the React documentation. Then you can search for declarative UI and you will see on this page the complete explanation of what I just mentioned. So now let's go back to Visual Studio Code. And now that we changed the status of the application, we just need to do some changes to the logic. So the first one is going to be to show this button. We are only going to show this button if the answer has not been submitted. If the answer has been submitted already, then we don't have to see this button anymore. So we are going to add this as another test. So we are going to show this button if we have an answer and if the state.gameStatus is not answered. Now we can do something similar for the result. So let me copy this logic. But here we are going to test if state.gameStatus is in fact equal to answered. And if it is, we are going to show the result component. So we can save this and go back there to test. So I'm going to refresh the page. So we have the options. I'm going to choose an option. Let me try changing it. Now I'm going to hit submit. And now we can see that we are not seeing anything in the page anymore. So let's go back there to check why is that. Here everything's correct. So let's see the logic that we set up in the app component. Let's remember that by the time we wrote this, we didn't have this answered state yet. So we are only rendering score and game if the status is ready. But we also want to keep rendering this if the state is answered. So for this one, I think it is just better to either show the loader or the error, or for any other state, we can just go ahead and render this. So we can remove this condition from here. And also this part right here. So now we can go back and test it again. So I'm going to refresh the page. We don't see the submit button. I chose an answer. I submit the answer. And as you can see now, the submit button is gone. We cannot click on it. And we are now seeing the result. So this is pretty cool. Now we just need to work on the logic to show the result. And this is what we are going to do in the next video. I'll see you then. Hey there, in this video we are going to work on the logic to show the result to the user. Since we are doing everything based on state and we are using declarative UI, this part is going to be extremely simple. So let's go to Visual Studio Code and let's go inside the result component. This is where we are going to show either this message or the message saying that the answer is incorrect. So for this, we're going to have to bring the state here. So let's copy this line of code and also the decode, because we're going to have to show the correct answer in case the user answers incorrectly. So let's take these two lines and let's also bring the line where we have the dispatch and the state. But here we are not going to need dispatch, only the state. So right here, remember that we are only showing this component if the user already answered. So we won't have to test that right now. We're just going to have to test if the answer is correct or not. So the test we are going to do here is the following. If state.userAnswer is the same as state.question.correctAnswer, and now TypeScript already included the question mark for us because this can be no, but this is very unlikely to happen. But anyway, let's leave it here. So if the user has the answer that is the same as the correct one, then we are going to show this version. If not, we are just going to show something different. So in this case, I'm going to use a class of incorrect. And what this is going to do is just change the color. So this is going to show as green. This is going to show as red. You can see this in the CSS files. So right here, we're going to change the message slightly. Let's remember that this is an HTML entity. If we go to Google to check this out, we will see that this is the HTML element for the check mark. And there is another one that we can use for the incorrect, which is going to be X274C. So as you can see, this is the symbol for the red X. So let's use that in our code. So instead of showing the green check mark, let's show the X and let's show your answer is wrong. The correct one was, and then we can dynamically show the correct answer. So now we can save this and go test that. Let me just close this page, this one as well. Let me refresh the page and we have the data right here. So let's see what is the correct answer. It's final. So let's choose final and hit submit. And once we do that, it says you answered correctly. Now let's try a wrong one. So the correct one is false. So let's try true, submit, and now your answer is wrong. The correct one was false. Pretty cool. Now we need to show this representation right here as well, because after we submit the answer, we need to show the correct one showing in green. So let's do that right now. So inside the answer option, we are going to add another class right here. So instead of adding this test like this, I'm going to add the backticks. And this is going to be one dynamic value. And now we can go ahead and add more classes. So I'm just going to break a line like this, just so we can see this better. So this is going to be one class. Then let's add a space right here, and we are going to add another test. So here we have to be careful because we can only show it in green after the user has submitted. So the first test we need to do here is if state.game status is answered, and if the answer is the same as state.question.correct answer. In this case, we are going to show the correct class. Now in this case, this element is going to have both classes, both selected and correct. This is not a problem because in the CSS, I wrote the correct one before this one with the same specificity. So this one is going to replace the selected. So let's do some tests. Let's go back to the browser. Let me refresh the page. Now let's try a wrong answer first. So we can open this and we can see that the correct one is 1024. So let's choose an incorrect one. And as you can see, we're not seeing which one is correct because the status is not answered yet. But once it is, let's submit. Now we can see that this is showing as correct. As these were not the same, this remained with the class of selected. Now let's try a correct one. So here we can see that the correct one is IMKO1. So IMKO1, we can submit. And now this option has both the selected and the correct class, but the correct one is prevailing. All right, so this is super cool. We are almost done with this project. I think in 3 more videos, we are gonna be done. So the things we need to do are, we need to show the next question button so we can keep playing this game forever. We need to update the score, and we also need to add the sounds for the answers. This is something that it's going to give a very nice touch to our app. So I can't wait to get to that part, and I'll see you in the next video. Hey there, in this video we are going to add the next question button so we can keep playing this game forever. This is going to be something super simple to do because we already have a function to fetch a new question. So let's go back to Visual Studio Code, let's go to the app component, and let's remember that every time we have a change in the state, we are going to run this function inside the use effect, and as long as the status of the application is on idle, then we are going to fetch a new question. And when we fetch the new question, everything will be done automatically. So we are going to set the status to fetching, and the whole cycle is going to start again. So the only thing we need to do to fetch a new question is just setting the status to idle. So let's go to the game component, and right below the result, down here, actually, it can be inside this same structure because we are going to show that button if the status is answered. So what we have to do here is just add a fragment. So we can add both inside. So we are going to have the result, and we are also going to have a button. The text of this button is going to be next question. And this is going to be styled already because I have everything on the CSS. If we save this and go back there, we can see that the button is correct. Now we just need to dispatch something when we click the button. And as I said, when using declarative UI, things start getting easier and easier as we progress. So here, the only thing we need to do when we click this button is just dispatch an action. So the type of the action is going to be set status. And we are going to set the status back to idle. And when we set it to idle, there will be a change in the state. We are going to run the code inside the use effect. And since we have it as idle, we are going to fetch a new question automatically. So let's save this and test it. Let me refresh the page. I'm going to answer something, submit. Then we can see the result message. Now I'm going to click next question. And as you can see, everything working perfectly. We see the loader because we are setting the status to fetching. And then when we receive the question, we render this on the page, which means that now we are able to play this game forever. Now, before we move on to the next video, let me just go back there. We can see that in the result component, we did not use decode, and we should have used decode right here because sometimes the correct answer will have those HTML entities as well. So let's use decode here. When we don't have any entities, that's not going to be a problem. We are just going to show the string as it is. So now we are not seeing any warnings and we are ready to work on the score. So I'll see you in the next video. Hey there, in this video, we are going to add the score to the context so we can keep track of how many we answered correctly and how many we answered incorrectly. So let's go to Visual Studio Code. Let's go to the context. And here in the quiz state, we are going to add another property. Let's call it score. And this is going to be an object that will have a property called correct, to which we will assign a number. And we are going to have another property called incorrect, to which we are also going to assign a number. Now for the initial state, we can just copy this. So we are going to have the score, and this is going to start at 0. Now here, it is a good idea that we create an interface for the score as well, because we are going to need it in the action. So we can go ahead and do that. We can come here and add an interface for the score. So this is going to be this object. And now we can just use the score type. And once we initialize it, TypeScript is seeing that these are valid values. So now we can go ahead and create the action to update the score. And for that, we are going to have to add it to the interface as well. So remember that we have a type for the quiz action. So we are going to add another union right here. This type is going to be set score. And the payload is only going to accept two values, correct or incorrect. And based on the payload, we are going to update the corresponding property. All right, so let's go down and create the action. So let's call it set score. But this is going to have to be done slightly different because we can't just change the score here. We need to know which property we need to change. So when we enter this case, we are going to create a new variable. We can call it score. And we are going to bring state.score. So we know what the current value is. Now we can do score and then use what we have in the action.payload as a property of this object. And then we can add 1 to whatever value it is now. All right, so now we can just return a new score and we can use the score. So we can save this, and this is not going to work yet because we are not dispatching this action from anywhere. So let's go to the game, and instead of dispatching the set status only when we submit, we're going to have to do a few more things. So it is better that we create a separate function instead. So let's copy this line of code. And here we don't need the arrow function anymore because we can just call a handle submit function, and we are not going to pass any argument from here. So let's go up here and let's create this new function called handle submit. And the first thing we are going to do is what we were doing before. So setting the status to answered. We can go ahead and test if everything's still working before we go ahead. So if we save this and go back there, let's try to answer something, submit, and as you can see, everything is still working normally. But now we will be able to do more things. So here we are going to add an if, and if state dot user answer is the same as the correct answer. So state dot question dot correct answer. Then we are going to dispatch set score, and the payload is going to be correct. If the answer is not correct, we are going to dispatch it with the incorrect payload. Now we can copy this line of code to use the state or use the context, and we can go to the score component and let's import it right here. Let's also use this line of code so we can create the state variable. We are not going to need dispatch from here, only state. So here, instead of showing the hard-coded 0, we are going to show state.score.incorrect, or in this case, the correct is coming first, so correct right here. And then the number for the incorrect answers. So now we can save this and we can test it. And let's see what is the correct one. So hexadecimal, let's choose it, let's submit. And now we can see 1 correct and 0 incorrect. Let's go to the next question and choose an incorrect one. So the correct one this time is false. So let's choose true. And as you can see, the score is updating correctly. Now there is one thing to fix here, because if we click next question, as you can see, without entering anything, we have the submit button right here. This is because we are not clearing the user answer value. So let's do that real quick. Let's go to the app component, and let's remember that when we fetch the question, we change the status to fetching, and we are also going to reset the user answer. So set user answer, and we are going to change it to no again. Now let's see if the user answer accepts no. So let's go to the context. So we have the user answer, and right here in the set user answer, as you can see, we are accepting only a string. So in this case, we need to accept a no as well. So now we are going to reset it. Let's test this. Let me refresh the page. I'm going to choose any answer here, submit. Now we see everything changing, and when we go to the next question, we are not seeing the submit until we choose a new answer. Pretty cool. Now there is just one thing to be done here, and in my opinion, this is the most exciting thing. So let's go to the final version. Let's remember that when we choose an incorrect answer, so let me submit, we have this sound. And now let's choose a correct one. Let's try this one. And now not only we have the sound, but we also have the confetti. So let's go to the next video so we can work on this part. I'll see you then. Hey there, in this video, let's add the last part of this project, which is the sound for the correct and incorrect answers, and also the confetti in case we get it correctly. So let's go to Visual Studio Code and let's start with the sounds. If you go to this public folder, you will notice that I left this sounds folder where we already have the won and the lost sounds. And in order to play this with React, first we need to create a new audio object. So I'm going to start a new variable and I'm going to call it won audio. So this is going to be a new audio object and we need to pass the path. Since we are inside the components folder, we could think that we need to jump out of it, then jump out of the source folder, but we don't. In React, everything that is in the public folder can be accessed directly as if this was in the same folder. So we can just use // and React will know that this is in the public folder. So here this is inside sounds and the name of the file is won.wave. Now we are going to do the same thing for the lost. And this is the lost.wave. Now, when we answer correctly, so right here, we can just do won audio.play. And if we get it wrong, then we can just play the lost audio. So we can save this, we can go back there and test. Let me just increase the volume so we can check if this is working. So the correct one here is false. Let's choose an incorrect first and submit. So we can see the sound being played. And now let's try a correct answer, which in this case is Novodex. So let's try it out. And we can see that the sounds are working correctly. Now we just need to add the confetti. For the confetti, there are some libraries that we can use. So I'm just going to search for npm confetti canvas. I think this was the one I used. So as you can see, there is this one that we can install and use. But for this example, I think it's just more complicated to add it as a dependency. I found one online that uses a CDN link and it's just easier to use. So I left the link for that before this lesson. So in the previous lesson, you probably saw a code to copy and paste. So now let's use that line of code in our project. Let's go back to Visual Studio Code and now we can import that library from CDN. So now all we have to do is run this function when we answer correctly. So let's try this out. I'm going to save this and go back there. Let me just refresh the page. And the correct answer is true. So let's submit. And now we can see that the confetti is working fine. Now let's just go back there to fix some TypeScript error. And we can see here that TypeScript didn't find the type declarations for this module. So normally when we import a library, we need to import the types as well. If you search for this error on Google, you will see that most libraries, they have a types library associated with them that you can also install in your project and you can avoid these TypeScript errors. For this case, we don't need to do any of that because we're just using it to execute this function right here. We don't need anything regarding types. So we can just ask TypeScript to ignore this. And we can do this by adding a comment before this line. And we can add @ts-ignore. So as you can see, the error went away. So now let's test it again. We can go back there. One thing that I forgot is to remove this from the console.log. So let's do this now. So let me just refresh the page. We can see that the console is clear. Let's test Saturn. This was the wrong answer. Let's try another one. I think this one is false. I think this is protocol. So let's submit and see. We get it correctly. We have the sound, we have the confetti, and the score is being updated. So we are now done with this project. I hope you enjoyed this section, and by now you should be more comfortable in using TypeScript in your projects. If you need any help from me, remember you can always use the Q&A section. So that was all for now. I'll see you soon.